Hello everyone, welcome to Reactive Labs. Today I am going to talk about a behavioral design pattern called strategy pattern. Okay, so let me write it down. Strategy pattern. Okay, so first let's understand why we need strategy pattern. What uh, what is something which this pattern is going to solve? Okay, and then we will understand what it actually is. Okay, uh, let's consider two things, actually two examples. Okay, uh, I'll take a complicated example first, then an analogy of that example, to explain it in simple terms. Because if I explain it in simple terms first, you will think that why do we need this pattern? Then it's too simple, like we could do it without this pattern. So that's why complicated example is required, and simple example I'll explain just to uh, make you understand that okay, this is how it works, but complicated will tell you why do we need it. Because when you are working on big projects, there are codes which are very complex, and to make that simple so that it's easy to maintain later and fix bugs later, it's easier, we need these design patterns. Okay, so let's say there is something called uh, there is a data, okay, that you are getting from somewhere. Okay, data getting from somewhere, let's say it's source. Okay, now that data has two things. Let's suppose there is a signal. Okay, and there is a deployment destination. Okay, so basically this data is wrapped, and when we extract it, we see that it has a signal and it has a deployment destination. Depending on the signal, we have to choose the destination. Okay, uh, now let's say the signal, I'll keep these signals smaller for now. Let's say the signal is um, Kafka. Okay, so for that, you know that okay, the signal is Kafka, so the destination would be Kafka. Now let's say the another signal is RabbitMQ, so destination is RabbitMQ, RMQ. Okay, so basically what I'm trying to convey here is that your data needs to be deployed in one of those services. Here I'm taking the services as message queues. Okay, so the deployment, where the deployment will happen, will depend on this type of signal. Okay, currently we have only two signals, Kafka and RabbitMQ, so we have these two destinations. So let's say in future we get multiple signals. Okay, before that, how are we going to handle this situation? We can just use an if else statement, like if the signal is Kafka, deploy to Kafka. Okay, similarly you will write else if signal is RabbitMQ, you can do deploy to RabbitMQ. Okay, this is good till this point. But let's say uh, in future the requirement comes up something like we are uh, degrading or downgrading, we are getting rid of Kafka. Okay, and we are getting some new signal like let's say our another new signal is dogMQ. Okay, tomorrow it should be catMQ, tomorrow it could be ratMQ. Okay, multiple possibilities are there. So for each one of them you will have to write okay, then if signal is dog then we have to deploy it to dogmq, right? So similarly for cat, you will do cat mq, multiple things will be there. And since the Kafka is deprecated now, so what you are going to do is you are going to remove this line, and then you have to remove this else from here. So there are a lot of things you need to do. Okay, so this is where the strategy pattern comes in. So if you see, what we need to do is we need to deploy. I'll make the screen larger. We need to deploy in all the cases. Okay, so basically what it means is there is a common function which is deploy. Okay, so let's say we have a common library, message queue, not library, it's an interface. Let's say there is an interface which is called message queue. Okay, uh, and this interface has a function called a deploy, and it is empty. This deploy function will be implemented in its child classes. So as of now we have two child classes called Kafka and RabbitMQ. Okay, each of these have their own deploy function. Okay, now when each of these have their own deploy function, they will be implemented in their own ways. And how we are going to then use this, like without going for the headache of this if else statement. Okay, so we know that there is a mapping between signal and destination, right? So what if we can do something which can give us a destination with respect to a signal? Let's say there is a map. Okay, and if we have a map of signal and destination, signal comma destination, then what we are going to do is we are going to map this signal with destination. Okay, so let's say our map is M. So in this map we will write, if the signal is Kafka, then we know that our destination is this, what? Kafka, the object of Kafka, basically new Kafka. So it will, the map is going to store this this destination that you see is just an object of these either Kafka or RabbitMQ, this. Okay, similarly when we have let's say RMQ as the signal, then for the map we have RMQ as the new object. Okay, and how are we going to use this? So we don't have to go for the if else statements, which can be quite lengthy and tedious and difficult to maintain. The only thing that we can do is we know that we have to call a function called deploy. Okay, so if we just let's say there is some other class called main which is going to use this. Okay, what are we going to do it is then, what did we get from the data? From the data we got the signal, right? Okay, so we are going to do just this, like we have a map, from that we took the signal. Okay, what did this signal give us? This signal is going to give us the object depending on that. Like now it's independent, whatever the signal data gives us, we know, like if the signal data gives us the signal Kafka, then we can see that okay, map has Kafka map to Kafka's object. Then if you just write deploy here, it is going to deploy to Kafka. We don't need to go into the tedious details of if else statements, right? So let's say tomorrow a new service dogmq comes. All you need to do is update that, okay, mapping of dmq says dogmq. Okay, and you will just create a new class called dogmq, and it will have its own deploy function. And let's say data gives us that now this is a signal for dmq, then this map will return the dmq object, and the dmq object will call the deploy function of its own, which is here, right? That's it, it's very easy. It may seem complicated to you. In that case, I'll take a simple example to explain this. Let's say there is an example of calculator. Okay, some app we are making, not calculator exactly, let's say we are making an app called calc app. Okay, it takes three parameters. number 1, number 2, and what do you say, this signal or sign or character, I'm writing it sign. Okay, so depending on the sign we need to perform some operation between two numbers. So let's say if sign is plus, then we have to return number 1 plus number 2, right? Similarly, if sign is minus, or just to make it fast we will write else. If sign is minus, then we return number 1 minus number 2. Right now we have only two signs. Let's say tomorrow we have some other data as well. Let's say somebody wants that if the sign is this, then we have to do number 1 power number 2. So this is number 1 raised to the power number 2, right? Let's say tomorrow there some comes multiplication, then it will be number 1 multiplied by number 2. Let's say tomorrow somebody comes and says division, then it will be number 1 divides number 2, right? There will be multiple such operations here. Okay, here you can say, why cannot we just use one method in which we can do all these things? Okay, you can use a method called do operation. Okay, and this do operation can do like it can take the signal and sorry, it can take the sign, and depending on that will perform the operation. But it is possible that for some of these like signs, the operations might be different. For example, let's say if there is a division, then we need an additional check, like if the number 2 is not 0. But if we are going to do the check for these, like if number 2 is not 0 for multiplication or addition, then it's just a waste of our resources. So we do not do that. Here, how can we again use strategy pattern? Let's see. What we are going to do is we are going to make an interface called operation. Okay, operation is an interface. It has a method called, let's say, perform something. Okay, then its children are uh, different operations will be there, right? Addition operation, subtraction operation. One more child will be multiplication operation. Currently, let's say we have only three, but if tomorrow something else comes up, for example, exponential operation, then we can just make a child exponentiation operation. Okay, and each of them will have their own perform function. Okay, addition has a perform function of its own. Subtraction has a perform function of its own. Okay, not this, just keep it empty for now. Multiplication has a perform function of its own. This also has a perform function for its own. Okay, everything has a perform function of its own, and each of these will have their own implementation, because they will have number 1 and number 2. Addition will just, what it will do, it will just do because we do not need any parameter for this, because we already know that it's for addition. At this addition class, it will just return n1 plus n2. This will return n1 minus n2. This will return n1 multiplied by n2. This will return n1 raised to the power n2. Okay, we know, so we do not have to do any extra calculations or additional parameters for this. And also it follows the design principles, that like each classes should be open for extension but closed for modification. If we have kept all of these in a single class, then we would have to modify the class every time we are going to perform something. But now if some other operation comes up, all we need to do is just create a new class for this, right? For example, division, right? That's it. Now what we have is, we know that there is a mapping between each sign and this class. For example, we have a map between sign and the interface operation. Okay, and the mapping is like m of plus is new addition, Because operation is an interface, we can do this. It's an interface of addition, we can do this. M of m of minus is new subtraction, right? We can do this. Now if somebody gives us some data that perform this operation, all we need to do is take the sign m of sign. What will this return? This will return us the object. Depending on if it's a plus sign, then it will return us an addition object. If it's a multiplication sign, it will give us a multiplication object. Dot perform. All we need to do is this thing in our separate class or main method, wherever we want. We just need to do this, and depending on the sign, it will take the object and perform the required function. I hope this cleared the strategy pattern. Please let me know if you found this video helpful. It will give me the motivation to make more such videos. I try to explain in my videos as detailed and in as simple way as possible. I try not to write code and more focus on logic. So because if you understand the logic, you will be able to write the code. You should know the important thing about writing codes is knowing what to write. So I hope this cleared it, and now you know strategy pattern better. If you have any doubts in understanding or any doubts which need to be clarified, please feel free to comment and I'll try to reply to them as soon as possible. And please let me know if you found this helpful and if I should make more videos on this. Thank you very much. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one. Thank you. Bye.